Chicos, greetings. We're doing double duty. On binomial expansion, and I want to get this to stop doing what it's doing. So this is 7.2 out of 7b out of the Holton Harris text, and mostly I want to show you how to find that Pascal's triangle without writing it all out. Of course, like memorizing it gets you street cred, but whatever. Not everybody needs street cred. So think about this. Let's say you got 3 people. Get these people out of there. And get these chairs out of there. Musical chairs. You got this lineup of chairs. How many different ways could you line these people up in the chairs? Different orders, right? So you could put ballerina in 1, and businessman in 2, and hipster chick in 3. Or you could switch those around, and like you could switch. I don't know. Like how many different ways could you do it? Well, there's maybe you want to pause me and like think about that, like kind of figure it out a little bit on your own. Just try it with 2 and 3. Okay, so I mean, one of the ways you could do it is like put ballerina in, and then you have put these in however you want. Then keep ballerina there and switch these, right? And then take that one out, put this one in, and these in whatever order, and then switch them, and then put hipster chick in, and then these in whatever order, and then switch them, right? So it was like I had 3 different people up front, and then each one of those had 2 different ways to mix and match. So I kind of said like 3 times 2. 3 times 2. And it's kind of like, it's sort of like I had 3 different ways to pick that first one. Like I could do 1, 2, 3 different ways. But once I picked that 3 different ways, there were 2 different ways I could pick the next chair, right? And once I picked that next chair, there's only 1 left over to go in there. So it's kind of like 3 and then 2 and then 1. And if you did this with more people and more chairs, you can kind of see that happening. So here's everybody else. This is a little more fun when everybody's together, and you can do this with the smartboard, but the same sort of thing happens. How many different ways can you line this up? Well, you have 5 different choices possible for this first seat. So how many different ways could you put somebody in the first seat? Well, you got 5 choices. So there's 5 different ways. And then after that, once you have somebody established there, there's 5 different ways you could put somebody in there. Once you have that established, there's 4 different ways you could put somebody in here, right? And once you have that, so that now there's 4 different ways just for this, right? Once you have that established, once you put slacker dude in there, you've chosen one out of those 4. Now there's 3 different people left, and so now there's 3 different ways you could put that third one in. And then once you have that, you get the idea. 2 different ways you can put the, oh, thank you, that's exactly what I need. 2 different ways you could put the last 2 in. And once you've selected gorilla for this side, there's only 1 place left. So you have 5 choices, and then 4, and then 3, and then 2, and then only 1, right? So that's pretty neat. What if you have 6 chairs and 6 people, or 10 chairs and 10 people, or n chairs and n people, right? You're probably guessing, right? You go, if you had 3 chairs and 3 people, when we had 3 chairs and 3 people, that was 3 times 2 times 1. And when we had 5 chairs and 5 people, we had 5 times 4 times 3 times 2 times 1. And if you had 6 chairs and 6 people, it'd be 6 times 5 3 to 1. And if you had 10 chairs and 10 people, it'd be 10 times 6 times. And if you had n chairs and n people, it would look like this. You'd start with n, and then you'd multiply by 1 less than n, and then you'd multiply by 2 less than n. Oh, 2 less than n. And then you'd multiply by 3 less than n, all the way down. You multiply by ... all the way down to 1, right? This is what we call n. n with this exclamation point is n factorial. This little exclamation point doesn't say n, it says n factorial, right? So this is the symbol for factorial, and all factorial means is multiply from 6 on down to 0. Stop at, 1. Stop at 1 because once you multiply by 0, the whole thing's 0. So n factorial, 6 factorial is 6 times 5 times 1, and 10 factorial is 10 times 1, and n factorial is n times 1 less than that, then times 2 less than that, times 3 less than that, right? This is 1 less than 6, this is 2 less than 6, 3 less than 6, 4 less than 6, all the way down to 1. And so, yeah, so like you're just multiplying out down to 1. Here's a sneaky trick. N is really like saying, n factorial is really like saying n times 1 less than it factorial. So I guess I have it written down, don't I? So 6 factorial is really like 6 times 5 on down, right? It's like 6 times 5 times 4 times 3 times 2 times 1. It's kind of a neat trick. So we're going to take this and bring it all together and hopefully find a use for it in binomial coefficients. I like this. Drop and give me 20. It's got the exclamation point, so it's like 20 factorial, which is, here, we can do it. Maybe we can do it. If you go into math, you go over to, oh, it's just in, it's in probability. Yeah. Go down to there, the exclamation point, it's factorial. So if you go 20, drop and give me 20 push-ups. But if you use an exclamation point at the end of it, it becomes that many, 2.4 times 10 to the 18th push-ups. She's like, I'm going to be here all night. So we can do this by hand, or we can also do it like that. Go to math, probability, the exclamation point. Some interesting ones are that you can just keep hitting second enter and then modify these. So 1 factorial is just 1 times 1. Interestingly, that one is 1 factorial too. And there's an interesting reason. Maybe you want to look into it. It might be a good like IA why that happens. It's another little interesting trick about patterns. That's kind of fun. But then the rest of them are pretty standard. 20 factorial is 20 times 19 times 18 times 7, and it's a really big number, obviously. Cool. Okay, so make sure you can find a few of those on your calculator. So here's a nice trick. Oh my god, n factorial. Here's a neat trick too. Things you can do with n factorials. So 8 factorial is 8 times 7, and 5 factorials is 5 times 5, 1. And what's interesting about them is these are always going to have some overlap. They're going to have some overlap. And since it's all the multiplication, the overlaps can cancel out, and you're just left with that, which is kind of cool. Yeah. So you try 9 factorial over 11 factorial, and I will check it on my calculator. Go. Don't wait for me. You do it, nerd. Okay, so I did 9 factorial in parentheses divided by 11 factorial in parentheses. I just wanted to be careful with the parentheses. I got, thanks. I got 1 over 110. Neat. So really, you could probably do this shorthand and know that 11 is going to go 11, 10, 9, 8, 7. The 9, 8, 7 and down is going to cancel with this, and so you should be left with 1 over 11 times 10. Huh? Right? You didn't even need the calculator. You get 1 over 110. Ching. Cool. All right. So there's another thing in your calculator right above the exclamation point. That's n choose r. NR. And so the IB likes to write them in this way. Also, you see them as NCR. And that's, well, it gives you the binomial coefficient. It gives you the numbers in front that come from Pascal's triangle. So sometimes you see it like that, or like that, or like that. The IB likes it like this, N choose R. And so if you put in your calculator, go to N choose R and put in, see if you can put in 40, 41, 42, 43, 44, and I will show you how to run it on this if you need. I'm going to go to math, over to probability, and go to N choose R. And so I'm going to try to find 40. So go 40, and you get 1. You can do the same thing, plug in 1, you get 4. You do the same thing, I'm hitting second enter, you go 2, and you get 6, right? Take a guess at what's going to happen when you put in 3. You guessed it, it's 4 again, right? 1, 4, 6, 4. And this is just a mechanical way, sort of. I mean, it's really the fundamental counting principle. But finding the coefficients in front of your values. So there's your 1, 4, 6, 4, 1, right? So that we're getting that out of this piece. So we're going to connect that and try to, in the future, put these values in front of your expansion, like when we do x plus 5 to the 12th. I don't want you to have to like build Pascal's triangle up to number 12. Hopefully you can kind of see that this is the row number and this is the number of terms into the triangle that you're going. And so right now, just for 7-2, I just want you to be able to find this mechanically, N choose R on your calculator. You can also do it with this sequence and series formula, but I don't think it's necessary for you to do that at this point. So first I'd like you to just try making sure you can get this with your calculator. And so this like 5 choose 2 would be the third thing you see in Pascal's triangle on the 5th column. So for example, if we were looking at 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. If I didn't want to do that, and I just knew that when I was expanding, I was trying to find like x plus 5 to the 5th, to the, sorry, 4th. 0, 1, 2, 3, 4, 5. 5. This is the 5th. This should be the 5th. If we were doing this to the 5th, and I was writing this out, and I know x is going to be the 5th, and then x is going to be the 4th, and x is going to be the 3rd, and I'm interested in this one for some reason. It's the 3rd thing in. So I know that in this row, I'm going to go 1, 2, oh, this 10 should be in front of this, right? And for some reason, I'm interested in this term. I'll show you tomorrow when you might be interested in that term. I want to know this 10 without having to build Pascal's triangle. You'd say, ask your calculator for 5 choose 2. Because this is the 0th thing you see first, second, right? Oh, sorry, first, second, third. So you do 5 choose 2, and you'd find that 10, and that's the thing that's in front. Okay, we'll deal with the mechanics of where it goes in the triangle and how it links up with the binomial expansion that we did yesterday in the next unit. But for now, I want you to understand how n factorial works, and also how to find like 5 choose 2 on your calculator. Cool, try that. There's a bunch of questions like there. Some of these are a little tougher, like with this piece, but they're not super necessary. I want you to just be able to calculate that piece, right? I was told there would be no homework. There's going to be some homework. Okay, bye.